Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this today we will start stack topic, and inside this we have 6 most important patterns, means varieties of problems we have in stack, out of which we will do the first pattern, which is monotonic stack. Let's do the first problem, which is next greater element. So here is the problem statement. You are given an array and the task is to find the next greater element for each element. As you can see in example, we have array 1 3 2 4. So for first element, which is 1, what is the next greater element? Next greater element means the first most greatest one. Means for 1, of course 3 2 4 all are greater, but out of all, which one is the nearest one? Can I say 3? Yes. So for 1, 3 is my next greater element. Similarly, for element 3, 4 is my next greater element. So I have added 4 here. Next time we have 2. So for 2, which is the next greater element? 4. So we have added 4. Now for 4, we have no such element found. So for this, we will write -1. So this is what the expected one. So let's come on to the screen. We have these elements and we have to print this. So can I say if I am present at 1, okay? If basically I have to go forward and I have to find which one is the which one is a greater and first greater, okay? So don't you think for the brute force, first we'll see the brute force approach and then we'll see how can we optimize and what is exactly monotonic stack means. So we will start our I pointer and j pointer. I represents key for this number we want, okay? Like this number we want the next greater, and j will take care of, it will run in the array and it will find the just next greater element to it, okay? So what do you think? You should start your j with exactly I, or you should start your j from the next? I think from the next, because even if you start your j from the exact number, it does not make sense. Means 1 is greater than 1, correct? So hence we will start this j loop from I plus 1, correct? Yes. So can I write that in similar way in code also? Okay, I want my I to run from I is equal to 0 till I less than n. N minus 1, because we are starting our j from I plus 1, so it is very important for I to stop here. And anyhow, for the last element, we don't have any further next element. So for every last element, the next greater element towards right will be nothing, means we have to update this with -1, correct? Okay, so can I say our answer variable, answer array, we will update everything for with -1 for the same size, okay? So I want my I to run till n minus 1, okay? Now what I want my j to run from I plus 1, so we will write another for loop for j starting from I plus 1. J we want to go till last and we will do j plus plus, yes. Now I have j. What I want to do? First, I have to check if my jth element is greater than I, means this is the first next greater element, yes. So if what? If array of j is greater than array of I, then what we want in our answer, answer, okay? So we want answer of I needs to be updated with what? Can I say answer of I is equal to answer of array of j? Yes. Answer of I means we want to find the next greater element for this ith index. So in answer of I we will update, but what value? Of course array of j, because array of j is greater than array of I, yes. So we want to update 3 in this index. So in this, here we will update 3. Now once done, do you think we should move our j forward? Means once we found key for 1 3 is the next greater element, do you still want your j to run forward? No, of course not. So after this we can break this j loop, okay? Done. Now next time I will be incremented for first index, so I will be here and we will again start our j from the next pointer. So we will try to find the next greater element for this 3. So we will run our j loop from here. So we will see array of j, which is 2, is this greater than 3? No, it is not. So hence this if will not run. Now next time j will move ahead and now we will find ki yes, this 4 is greater than 3, means array of j is greater than 3. So we will update, yes. Now do you think we should move forward? No. So first let's update 4 here and we will not move forward. So now next time again I and j will reinitialize for next index, and j we will start from here. Now we find ki yes, j is greater than I, so we will update this by 4, and now next time do you think we will move our I pointer ahead? No, because if we will move our I pointer ahead, we will it does not make sense, because we are always starting our j pointer from I plus 1, correct, and here it is out of index. So we will stop our ith index at second last index itself. So after this, we after coming out of these two for loops, we can return as it is, correct. But what is the time complexity here? If you see, the first for loop is running for n number of times. N minus 1 means O of n only. Yes, and inside this also j loop we are running for n number of times. If you see ki we are to breaking when we are getting, but think of the worst case scenario. When will be the worst case? When this the array, input array is sorted in descending order. Means suppose you have 9, 8, 7, 6, 5, 4, 3 and till 1. Okay, so what you will do for 9, your j will start from here, it will keep running in search of greater element, but it won't found anything, but still you are running your j for n number of times now. Next time when your I will be here, again you are running your j for n minus 1 number of time, n minus 2 number of times, and so on. So basically this will take O of n square time complexity. And if you read the constraint here, if you see array size can go till 10 power 6, means if n is 10 power 6, definitely n square will become 10 power 12, and you know beyond 10 power 8 it might give us TLE, and beyond 9 into 10 power 8 or 8 into 10 power 8 and beyond 10 power 9, to for sure it will give us TLE, correct. So as it is 10 power 12, so this will give us TLE. So here is the code which we just wrote, the pseudo code, correct. We are running this for loop second time, and we are checking whenever we are getting this, saving this in next greater element. Now you can either update this here only and then break, and even if you are saving this in variable, after breaking this first inner for loop, you will come at this line and you will save in your answer variable. Okay, why we are adding in the answer? Because this answer is a array list, because the return type of this function is array list. If it was array, then we would have inserted our answer with the help of indexing. I hope you know this. So this is the code. Now let's try to run this, and because it takes O of n square, so when we will submit this, definitely this will give us TLE. Yes, as expected it gave us TLE, because the time square, total time complexity will be O of n square, which is 10 power 12. So how can we optimize this? Always remember, whenever wherever you are seeing such type of code where to find the greater element or smaller element, you are running these two for loops. Which two for loop? For every I, either you are moving your j ahead, or either you are moving your j behind till 0. You can think of using stack data structure, and this is the most important point to identify where to use a stack. And also we can reduce our total time complexity from O of n square to O of n by just running one for loop instead of two. But how we will do so? Let's see. First, initially we were at here, correct? So if I am at here, I don't know, for the next greater element, for sure I have to travel everything, correct. Similarly, if I am at here and I have to find the next greater element towards right side, again I have to move forward till end, correct. Okay, but I don't want to run two for loops. So for this case, why not to start from the right side? Why? See, if I am starting from here, I know for the last value anyhow it is -1, correct. Yes. So let's say we have answer variable and we have initialized -1, -1, -1 and -1. Okay, so anyhow for this 4 we won't start. Okay, now why I am starting from this side? Because I will keep a track of the greater element. How? Now suppose I move to 2. Okay, so what I will do, previously when I was at 4, I'll keep this in stack. This is the logic, okay, in the stack. Now if I encounter 2, I'll check ki do I have any value in my stack? Yes, I have. Okay, if yes I have, do I need to check it is greater? No, I won't check. This is the idea. Now we will compare this 2 with the stack top element only if stack has some elements. Okay, so in this case stack has 4. Okay, so we will check with this, is this 2 is greater than the stack top element? No, in this case it's not the case. Means for 2, 4 is my answer. Okay, so means we will keep this 4 in the stack and also we'll consider this 4 as answer here. So means we will update this with 4. Done. And now we'll insert this 2 here. Why we did? Let me show you. Now next time we encountered 3. So what we will do, see this carefully. We are at 3. We want to compare this. We'll check, is our stack empty? No, it is not. So what we'll do, 3, is this 3 greater than 2? Yes. It means for 3, 2 is not greater element. So in stack, like we are maintaining our stack such that we will only put the greater element till now. Okay. So as I know ki for 3, 2 is not the greater element. So I can blindly remove that. But why I am removing? I am removing because of 2 reasons. First reason is for 3, 2 is not the greater element. So we want the next element and we don't want to iterate it again. So O of one time I'll take to pop, okay, and next value I can take it, correct? Yes. Another reason I want to delete is because this 2 is what? Smaller than 3. So for sure in future whatever element we will encounter, correct? Suppose we encountered 1, correct? So either this 3 will be the greater element, 2 cannot be, okay? Or else suppose it has 0, okay? So for 0 either 1 can be the greater element, correct? Or if we had 2 here, then for 2, 3 can be the greater element, correct? But this 2 will never be the greater element because we are checking towards the right side and we found now 3 is greater. So definitely 3 will be the greatest element. So hence removed from the stack. And now again we'll check for 3. Is this 4 also lesser? No, it is not. It means 4 will stay here only and for 3, 4 is the next greater element. So we will update this with 4. Now 3 also we will insert. Now we will check for 1. We'll come here at 1 and we'll see ki hey, is this 1 is greater than the stack top element? It means suppose if it has 0, then for sure for 1, 0 is not the greater element and we will pop. So in this case I found 3. It means for 1, 3 is my greater element and I will insert this 1 in my stack. Now suppose after this I have 0. So definitely for 0 the greatest element will be in the stack only, topmost value of stack, okay. But now suppose instead of 0 we had 3 again. So for 3, is this 1 greater? No. So we'll pop. For 3, is this 3 greater? We want greater element, okay. So no, 3 is equal, pop. Now if for this 3, is this 4 greater? Yes. So what I'll do, I'll simply add here 4. Yes, for 3, 4 is a greater element. Why we started from right side? Because in this question it asks the next greater elements towards the right side. If the question will ask to find the next greater elements from left side, then we will start our for loop from left side instead of the right end. Okay, so now let's write the pseudo code for everything we have discussed. First we will run the for loop from where? Can I say last index? Last index means n-1 where n is the length of array, and will go until I is greater than equal to 0 and I minus minus, okay. So for the very first value what we'll do, if first I'll check if my stack is empty or not. So we'll check if my stack is not empty, okay, if my stack is not empty, okay. What is the condition for pop? If you remember, ki stack needs to be not emptied, correct, first, and along with that what was the next condition, ki if my stack dot peak means top value, if this is smaller than or equal to the current value, which is nothing but array of I, correct. Means if stack dot peak means top element, suppose here in this 3, for 3 1 is smaller, so we will pop. Again for 3 is equal to, so we also want to pop. So we will keep on popping, means stack dot pop we will do. But do we want to do this only for one time or we want to keep doing this until the condition satisfies? Of course. So instead of if, we will use the while loop here. Okay, so for this 3, suppose this 1 has been popped out and 3 has been popped out. Now next time as this condition fails because this 4 is greater, so this while loop will stop. Now for this 3 what I want to put this 4 in my answer, correct. So what I'll do, I'll check, basically I want to put what in my answer variable, answer of index I want to put stack dot peak, but before doing this peek operation, I have to check if my stack is not empty. So again I will do if not stack dot is empty, means if my stack is not empty, then I would like to put this answer. Okay, now done. Now what we would like to do, definitely we would like to add this 3 in my stack here, correct? So we will do stack dot push this 3. This 3 is nothing but array of I, and after coming outside we can simply return this answer array. Okay, so now if we'll see the time complexity here, definitely we are taking O of n because we are running this I from the last index to the first index, so O of n. And if you are thinking about this while loop in the nested and you are thinking O of n into O of n, no, it is not n square, it is 2n. Why? Let's see. First, this for loop, you are very much sure that this will take only O of n, correct? Because we are not reinitializing our I again from the last index. Yes. Now talking about this while loop, what does this while loop is doing? Of course it is popping, but once like whatever index it has popped from here, do you think it will again, like these elements will again get refilled here and again it will pop? No, na. Like it does not pop 4 because it was not in the condition, but it does pop 2 when 3 came. Okay, now it pushed this, now 3 came, it popped this, correct? So in total, if you see now, in worst case also, worst case means suppose the like array is sorted in descending order, means 4 3 2 1. Okay, so definitely 1 will go. When 2 encounters, 1 will get popped. When 3 encounters, 2 will get popped. When 4 encounters, 3 will get popped and will come out of this. So we will see now this while loop has actually run for exactly O of n time only. So in total O of n plus O of n, which is 2n instead of n square, and this is far better solution compared to the previous one. So here is the code which we discussed. We will initialize the answer array, and because it is the array list, okay, so we will initialize and fill this -1 inside this because array list does not have fixed size, and we'll initialize the stack. Now we will run the for loop with the help of I, where I will start from last index and it will go till 0. Okay, now we'll check in our while loop if our stack is not empty and the topmost value of stack is lesser than or equal to the current element found, means I can say that the stack top element is not my greater element. So let's pop it until the condition satisfies. After coming out, definitely whatever kept in my stack will be my next greater element. Yes, if the stack is empty, means nothing, means anyhow by default we have -1 already there. So if a stack is not empty, means that value we can put as, because it is a greater element. And at last, anyhow, either the current element was smaller, greater, no matter, every value will go in my stack for once, and after coming outside we will return, and the time complexity is O of 2n, which is linear only. So we can run this and we can submit this, and for this time this will be faster solution as expected. So here is your Java code. I hope you understood the logic. The only thing is this was about next greater element towards right. If the question says next greater element towards left, remember you just have to change this for loop's direction, means you have to start your I from 0 instead of n-1, correct? So here is a Python code with the similar logic. Code is very small and it is linear one, and here is your C++ solution if you guys are from C++ background. So I hope you understood. With this we can go in our sheet and we can mark the very first question as done. So this was your GFG solution, and this was a standard next greater element problem. But if you read the problem of LeetCode, then you will get to know ki yes, of course you have to check the next greater element only, but only for those elements which are there in nums1, means first you will create the next greater element for nums2. So let's say for nums2, which is 1 3 4 2. Okay, so how the next greater element array will look like? Can I say for 1 3 will be there, for 3 4 will be there, for 4 nothing, and for 2 also nothing, correct? So this is the next greater element function will do, which we have learnt. Now as per nums1, what we have to do, it says for 4 tell me the next greater element. So for 4, what was the next greater element? -1. So this is what we have to return, -1. Now for 1, now you go in the next greater element. For 1 it was 3, so you have to say 3 here. Similarly for 2, so in next greater element you will find ki for 2 you found -1 as an answer, so this is what you have to return. Okay, so this was the problem statement of LeetCode. I hope if you know how to calculate the next greater element, then this question also you can do it easily, as the question mark also easy. But still, if you find it difficult, do let me know in the comment section and I will definitely make a video on this. So with this we are done with the very first question of stack, and I hope you guys are doing along with me and understood the reason of brute force and optimize and why we have to use a stack data structure here. So that's it guys. If you are watching till now, please do like the video and subscribe it if you not yet subscribed. And if you guys are new to this channel, we are following the pattern wise DSA sheet and the link you can get from the description. And that's it. Let's meet in other videos with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.